Buying the wrong CPU is one of the most expensive mistakes you can make in a PC build, and the industry makes it deliberately confusing to get it right. Core counts, thread counts, TDP ratings, cache sizes, platform compatibility, DDR4 versus DDR5, brands bury buyers in specifications designed to justify pricing, not to help you make a smart decision. Today, we cut through all of it. We are counting down the only 10 CPUs in 2026 actually worth buying, from budget processors that destroy what people assume $40 of silicon can do, to a number one that has ended the argument about what desktop performance looks like at any price. Whether you are building your first PC on a strict budget or assembling a workstation that will not ask you to compromise for the next 5 years, this list has the right answer for you. Stay until number 1. That processor is in a category of its own. Number 10. Intel Core i3 100F. Let us start with the most important thing the PC building community rarely says plainly enough. The Intel Core i3 100F is the proof that entry-level does not mean inadequate, and that spending more than you need to on a CPU is one of the most common and most avoidable mistakes a first-time builder makes. The i3 14100F is a 4-core, 8-thread processor built on Intel's Raptor Lake architecture, and within its lane it performs every task a mainstream user actually asks of it without hesitation. Gaming at 1080p with a capable GPU produces frame rates that are indistinguishable from processors costing 2 to 3 times as much, because modern gaming is overwhelmingly GPU limited, and a CPU that feeds the graphics card fast enough is a CPU that has done its job completely. The F designation means no integrated graphics, which is a meaningful cost reduction that only matters if you are building without a dedicated GPU. For any gaming build, it is irrelevant. The LGA 1700 socket platform provides access to DDR4 and DDR5 memory compatibility depending on your motherboard selection, and the 58W base power draw keeps thermals manageable on modest coolers, without demanding premium thermal solutions. The included Intel cooler handles the processor's heat output competently, a detail that saves additional budget for GPU, storage, or memory upgrades that deliver more tangible improvements. At around $109, the Intel Core i3 Hover 100F is the most honest processor on this list. It does not try to be more than it is. For light gaming, everyday productivity, and budget streaming builds, it earns every dollar of its asking price. Number 9. AMD Ryzen 5 5600. Here is the uncomfortable truth that AMD's newer processor lineup does not want you to sit with too long. The AMD Ryzen 5 5600 is a 3-year-old processor architecture that continues to outperform expectations in 2026 because the Zen 3 architecture it is built on was so competently engineered that time has been unable to make it obsolete in the tasks that most users actually perform. 6 cores and 12 threads on a 7nm process node deliver gaming and productivity performance that competes credibly with current generation processors at higher price points. In gaming workloads, the 5600 operates in near identical frame rate territory to significantly newer designs, a finding that reinforces the reality that beyond a performance floor, additional CPU investment in a gaming build contributes diminishing returns. The AM4 platform advantage is the 5600's most quietly powerful feature. AM4 is the most widely supported and most affordable mainstream CPU platform in existence. Budget motherboards are available at prices that significantly reduce total platform costs compared to AM5 or LGA 1200 alternatives. DDR4 memory, which the platform requires, trades at a fraction of DDR5 pricing. The total system cost advantage of building around the 5600 and AM4 is substantial, and that advantage translates directly into a better GPU, more storage, or faster memory for the same overall budget. The 65W TDP keeps the processor cool on the included Wraith Stealth cooler without additional thermal investment. At around $119, the AMD Ryzen 5 5600 remains one of the finest value propositions in desktop computing, a processor that the passage of time has made cheaper without making worse. Number 8. Intel Core i5 14400F. The Intel Core i5 400F is the machine that makes mid-range CPU pricing feel dishonest because it delivers 10-core, 16-thread performance at a price that competing processors charge significantly more to match. Intel's hybrid architecture places 6 performance cores alongside 4 efficient cores on a single die, assigning workloads intelligently based on their computational demands. Gaming, single-threaded applications, and latency-sensitive tasks run on the performance cores. Background processes, compilation tasks, and sustained multi-threaded workloads leverage the efficient cores to maintain system responsiveness without throttling the primary workload. The practical result is a processor that handles simultaneous gaming and streaming, content creation alongside active productivity applications, and heavy multitasking workloads with a composure that pure 6-core designs cannot match. The 14400F's cache allocation, 20 MB of Intel Smart Cache, provides a data buffer that reduces main memory latency for gaming workloads, delivering frame time consistency that raw clock speed comparisons between processors do not reveal. The F designation removes integrated graphics and reduces cost. In a dedicated GPU build, that cost reduction is pure value with no functional trade-off. DDR4 and DDR5 platform flexibility through LGA 1700 motherboard options gives builders a choice between the affordability of established DDR4 infrastructure and the performance ceiling of DDR5. At around $179, the Intel Core i5-400F delivers 10-core hybrid performance at a price that makes the step up from budget computing feel like the right decision made at exactly the right time. Number 7. AMD Ryzen 5 7600. The AMD Ryzen 5 7600 is where AMD's Zen 4 architecture becomes accessible, and it makes that accessibility count with the 6-core performance output that resets expectations for what a mid-range processor should be capable of in 2026. Zen 4 brought meaningful architectural improvements over Zen 3 across every metric that matters for real-world performance. Higher instructions, per-clock efficiency, improved branch prediction, larger cache allocations, and a 5nm process node that delivers those improvements within a thermal and power envelope that is remarkably controlled for the performance it produces. The 7600 achieves single-core performance that leads its price tier, and single-core performance is the metric that gaming frame rates, application launch times, and everyday desktop responsiveness are most directly determined by. 6 cores and 12 threads handle modern gaming workloads, light content creation, and simultaneous background tasks without strain. The integrated RDNA 2 graphics on the AM5 platform provide functional display output for system diagnostics and budget builds without a dedicated GPU, a platform utility that F-Series Intel alternatives cannot offer. The AM5 platform itself is AMD's long-term investment signal. AM5 support has been committed through 2027 and beyond, meaning a Ryzen 5 7600 build today is a foundation that can be upgraded to significantly more powerful processors without a platform change. DDR5 memory is the platform requirement, and while DDR5 pricing has normalized considerably, the total platform cost sits above AM4 alternatives. The performance delta justifies that investment for builds that will be used and upgraded over multiple years. At around 109 beneath, the AMD Ryzen 5 7600 is the entry point into Zen 4 that the platform deserves. Fast, efficient, and built on a foundation with genuine longevity. Number 6. Intel Core i5-14600K. The Intel Core i5-14600K is the processor that enthusiast builders return to when they want honest, consistent, high-performance computing without the premium pricing of flagship silicon, and it earns that loyalty with a combination of raw performance, platform maturity, and overclocking headroom that its price tier rarely delivers together. 14 cores in 6 performance, 8 efficient, and 20 threads represent Intel's most aggressive hybrid core configuration in the mainstream segment, and the performance output reflects that ambition. The 14600K matches or surpasses AMD's Ryzen 7 7700 in gaming workloads while undercutting it on price, a competitive positioning that makes the purchasing decision straightforward for buyers prioritizing gaming frame rates per dollar spent. The K designation enables unlocked multiplier overclocking, which means the processor's clock speeds can be pushed beyond factory specifications with appropriate cooling and a compatible Z-series motherboard. Experienced builders regularly push the 14600K to all-core frequencies that breach the performance territory of processors one tier above it, extracting additional value from hardware that already represents strong value at stock settings. The 24MB Intel Smart Cache allocation provides one of the largest cache buffers available in its price range, reducing main memory bandwidth dependency for gaming workloads and producing frame time consistency that lower cache competitors at the same price struggle to match. Thermal performance under sustained loads demands a quality air cooler or entry-level AIO liquid cooler, an investment that the performance headroom this processor offers justifies immediately. At around $249, the Intel Core i5-14600K is the finest performance per dollar mainstream processor Intel offers in 2026. For builders who want flagship gaming performance without flagship pricing, this is where that search ends. Number 5. AMD Ryzen 7 7700X. The AMD Ryzen 7 7700X is where the processor conversation shifts from value optimization to genuine performance ambition, and it makes that shift with an 8-core Zen 4 configuration that handles every mainstream workload thrown at it with authority and efficiency that more expensive alternatives struggle to meaningfully improve upon. 8 cores and 16 threads on the Zen 4 architecture deliver a performance profile that is simultaneously a best-in-class gaming processor and a capable content creation workhorse. Video editing in DaVinci Resolve and Premiere Pro, 3D rendering in Blender, software compilation, and streaming simultaneously with gaming. The 7700X handles the full range of prosumer workloads without the performance cliff that 6-core processors encounter when multi-threaded demands accumulate. The 105W TDP reflects AMD's decision to prioritize clock speed and performance ceiling over power consumption. The 7700X boosts to 5.4 GHz on its fastest core, a frequency that translates directly into the single-core performance advantage that makes AMD's Zen 4 lineup the gaming benchmark reference across the industry. The 32MB L3 cache allocation is among the largest available in the mainstream 8-core segment, producing gaming frame rate consistency and minimum frame performance that smaller cache competitors consistently fail to match under identical conditions. The AM5 platform's DDR5 memory subsystem works in concert with the 7700X's increased memory bandwidth requirements, enabling the processor's full performance potential in a way that DDR4 limited platforms cannot replicate. A quality 240mm Alberton AIO cooler is the recommended thermal solution for sustained workloads. The X variant's aggressive boost behavior rewards proper cooling with sustained clock speeds rather than thermally induced throttling. At around $299, the AMD Ryzen 7 7700X is the 8-core performance standard for mainstream builders who refuse to settle for adequate when exceptional is accessible. Number 4. Intel Core i7-14700K. The Intel Core i7-14700K is the machine that changes the calculation for serious builders, the point at which Intel's hybrid core architecture reaches a core count and thread count that handles both gaming and professional workloads simultaneously without asking the user to choose one as a priority. 20 cores, 8 performance, 12 efficient, and 28 threads represent a multi-threaded capability that previously required workstation-class processors and workstation-class pricing. In gaming, the 14700K delivers frame rates at the absolute ceiling of what any single processor can contribute to GPU-driven performance. The performance cores boost to 5.6 GHz, ensuring that no game engine currently in production is CPU limited with the silicon in the system. In professional applications, the 20-core configuration handles sustained rendering, compilation, and multi-threaded creative workloads with a throughput that competes directly with AMD's Ryzen 9 class at a price that undercuts it meaningfully. The 33MB Intel Smart Cache allocation is the largest available in Intel's mainstream lineup and provides a data buffer that reduces DRAM latency dependency for applications that benefit most from proximity to fast cache, game engines, real-time audio processing, and financial modeling workloads among them. The K designation's unlocked multiplier with the Z790 platform motherboard enables overclocking that pushes performance core frequencies beyond factory limits for builders willing to invest in premium thermal solutions. DDR5 memory support at frequencies above DDR5 6000 delivers measurable bandwidth improvements for memory-sensitive workloads that earlier platform generations could not accommodate. Power consumption under sustained all-core load is significant. The 14700K is not a processor for small form factor builds or modest cooling budgets. It rewards the platform investment it demands. At around $379, the Intel Core i7 Sakura 700K is the finest simultaneously gaming and professional processor Intel has produced for the mainstream market. For builders who refuse to maintain separate machines for work and play, it eliminates the need to choose. Number 3. AMD Ryzen 9 7900X. The AMD Ryzen 9 7900X is where this list enters territory that demands a different kind of buyer. Someone who understands that the performance gap between processors at this tier and everything below is not measured in percentages, but in capability. Tasks that constrain 8-core and 10-core designs become routine. Workloads that would take hours complete in minutes, and the sustained performance output across extended professional sessions reveals the difference between a processor engineered for productivity and one engineered for specification sheet positioning. 12 Zen 4 cores and 24 threads represent AMD's first move into genuine HEDT-adjacent performance on a mainstream platform. The kind of multi-threaded throughput that video production studios, software development teams, and data science workflows depend on delivered through a platform that takes standard DDR5 memory and standard AM5 motherboards. The 5.6 GHz maximum boost frequency ensures that single-threaded gaming performance does not regress as the core count scales. The 7900X is simultaneously a 12-core productivity powerhouse and a top-tier gaming processor, a combination that previous generation high-core count designs consistently failed to deliver. The 64MB L3 cache allocation, double the capacity of the 8-core 7700X, produces gaming minimum frame rates and multi-application performance consistency that the enthusiast community consistently identifies as the 7900X's most underappreciated advantage. AMD's Precision Boost algorithm manages the 12 cores frequency and power draw with a real-time intelligence that extracts maximum single-core performance when the workload demands it and maximum multi-core throughput when parallel tasks benefit from it, without manual profile management from the user. A 360mm AIO liquid cooler is the appropriate thermal investment for sustained professional workloads. The 100cm TDP reflects the performance ceiling this processor operates at under load, and thermal headroom directly determines how long that ceiling can be sustained. At around $399, the AMD Ryzen 9 7900X is the finest 12-core processor available to mainstream builders. For content creators, developers, and professionals who need workstation-grade throughput on a desktop platform, it is the most convincing argument in the market. Number 2. Intel Core i9 14900K. The Intel Core i9 14900K is the machine that Intel built to leave no performance argument unresolved. A processor that approaches every benchmark, every workload, and every competitive comparison with the confidence of a brand that has spent 70 years defining what computing performance looks like. 24 cores, 8 performance, 16 efficient, and 32 threads represent the highest core count available on Intel's mainstream LGA 1700 platform, and the performance output across both single-threaded and multi-threaded workloads reflects the full ambition of that specification. The performance cores boost to 6.0 GHz, the highest factory-rated boost frequency available in any mainstream desktop processor in 2026, producing single-core performance that sets the absolute ceiling for gaming frame rates, real-time audio processing, and latency, sensitive professional applications. In Cinebench multi-core video export throughput and software compilation benchmarks, the 14900K competes at workstation processor levels through a platform that costs a fraction of HEDT alternatives. The 36TB Intel Smart Cache is the largest L3 allocation in Intel's mainstream history, a data buffer that enables sustained high-frequency compute performance across workloads that would exhaust smaller cache designs with main memory round trips. Overclocking potential through the unlocked K multiplier and Intel's performance maximum technology allows experienced builders to push the 14900K to all core frequencies that breach 6.2 GHz with premium cooling and platform support, territory that no AMD Ryzen 9000 series processor has challenged in single-core workloads. The thermal and power profile is the 14900K's honest trade-off: 125W base and up to 253W sustained under turbo boost. Maximum technology demands serious cooling infrastructure. A 360-meter AIO or high-end air cooler is not optional at this performance level. It is a prerequisite. The Z790 platform with DDR5 memory at XMP frequencies completes the system configuration that allows the 14900K's performance ceiling to be reached consistently. At around $499, the Intel Core i9-14900K is the most capable processor Intel offers to mainstream builders, a declaration of maximum performance that requires no qualification about what it cannot do. Number 1. AMD Ryzen 99950X. The AMD Ryzen 99950X is the end of the conversation. Not the end of the roadmap, not the ceiling until next year's release, but the definitive answer to the question that every serious PC builder eventually arrives at. What does the finest desktop processor available to a mainstream buyer in 2026 actually deliver? And does the experience it produces justify the investment it demands? The answer is yes. Unequivocally and without asterisk. The Ryzen 99950X is AMD's Zen 5 flagship for the mainstream AM5 platform. 16 cores, 32 threads, and an architectural generation that delivers improvements over Zen 4 in instructions per clock efficiency, branch prediction accuracy, AI inference throughput, and memory subsystem bandwidth simultaneously. These are not incremental refinements. Zen 5 represents a foundational redesign of the core architecture that Zen 4 was built on, producing per-core performance improvements that translate directly into faster single-threaded applications, higher gaming frame rates, and more responsive desktop experiences across every use case the processor is asked to serve. The 99500X boosts to 5.7 GHz on its fastest core, and unlike clock speed increases achieved through power delivery scaling, this frequency is reached through architectural efficiency improvements that deliver it within a thermal envelope that is remarkably controlled for a 16-core flagship. The processor's base TDP of 170W manages 16 Zen 5 cores, with a composure that Intel's comparable flagship cannot match within the same thermal constraint. The 64MB by L3 cache allocation feeds 16 cores with data proximity that eliminates main memory latency as a performance bottleneck across every workload category: gaming, rendering, compilation, simulation, and AI inference. All benefit from cache capacity at this scale in ways that smaller cache designs reveal only under sustained professional use. AMD's Precision Boost Overdrive technology provides a framework for platform-aware performance scaling. The processor assesses the thermal headroom available from the cooling solution, the power delivery capacity of the motherboard's VRM, and the thermal state of the die, and adjusts boost frequency and duration accordingly. The result is a processor that consistently operates at or near its performance ceiling without the manual tuning that extracting maximum performance from competing designs requires. The AM5 platform brings a maturity in 2026 that the launch window experience lacked. DDR5 pricing has normalized. XPO and XMP DDR5 memory kits at DDR5 6000 and above are widely available and directly supported. And AM5 motherboard options span from capable mid-range to premium enthusiast configurations. The platform investment that the 99950X demands is an investment in a foundation that AMD has committed to supporting through future Ryzen generations. The processor you install today exists on a platform that will accommodate meaningfully faster silicon without a platform change. For content creators working in 8K video, architects running real-time render previews, engineers running finite element analysis, developers compiling large code bases, and streamers running broadcast quality encoding simultaneously with gaming. The Ryzen 9 9950X does not ask them to schedule workloads around hardware constraints. It removes those constraints. For the builder who wants a single machine that handles the most demanding professional workloads and the most performance-hungry gaming titles with equal authority, without the compromises that fewer cores, smaller caches, or previous generation architectures impose, the AMD Ryzen 9 9950X is the only answer in 2026.